Hello everyone, the assistant browser MBCCET pyramid. In this video, we are discussing about comparator with op-amp. An operation amplifier in the open loop configuration operates in a linear manner. In this case, there are a number of applications of op-amp in this mode, such as comparators, limiters, and digital interfacing devices, namely converters. A comparator is a circuit which compares a signal voltage applied to an input of an op-amp with a non-reference voltage at the input. So, simply, op-amp, this is our output voltage. So, this voltage is positive and this voltage is negative. So, positive and negative voltage. So, we know about V out is equal to open loop gain into VID. So, but plus V2. So, into V1 minus V2. So, this is an open loop condition. So, we can make the any one of the input voltage. So, voltage is referred to as voltage and compare other input voltage with respect to our voltage. So, comparator have number of important usage in instrumentation systems, values or any quantity level. So, we can compare the input temperature, compare with the reference voltage. We can make the particular value based on the particular voltage. So the temperature is exceed or in a certain value. So that can detect by the comparator. So the value is exceeding or the value is particular value is that also can detect by the comparator. So are basically two types. So comparator and so comparator simply compare the two voltage levels and we will get the second output voltage. So if the value is V1 is higher than the V2, the voltage higher than V2, we will get the high voltage, and V1 is less than V2, so low voltage. So we can predict the high voltage and low voltage is plus or minus Vsat, saturation voltage of the op-amp, because the op-amp is working in open loop configuration. So of the comparator. Now in this video included the working of the non-inverting comparator and the inverting comparator, and also the one application of the comparator, that is zero crossing detector. So first we will discuss about the non-inverting comparator. Non So comparator namely compare the two inputs. So in this non-inverting comparator, name stands the input is connecting to the non-inverting terminal. So this is positive and negative. So we can apply the input to the positive one, that is Vi, and the non-voltage, that is the reference voltage, is applied to the terminal, and there is a two resistors here. Two equal values are added to the, so the same values are. So this is the circuit diagram of the non-inverting configuration, and there is a output V out is here, and with respect to a load resistor, that is RL. So okay. So this is of the non-inverting comparator based on this one. V1 is greater than V2, we will get the higher output, and V1 is less than V2, we will get the low voltage because of the equation V out is equal to open loop gain into V1 minus V2. So the maximum voltage is plus or minus saturation voltage of the output. So of the non-inverting comparator, voltage is the reference voltage is applied to the negative terminal of the op amp, and a time varying signal Vi is applied to the non-inverting terminal of the op amp. So these are the cases when the input less than reference voltage, output V out is equal to minus saturation voltage, Vi greater than voltage plus Vsat, because this is a voltage, is the negative voltage is here. So whenever the voltage is less than that of the input voltage is less than that of the reference voltage, we got the negative one. Compare this one. V1 is less than V2, we got the low voltage. Low voltage in this case, that is negative Vsat. So one, that is greater than V2, we got the higher output. So higher output in the open loop case is plus Vsat. So we can make the waveform or the working of the non-inverting comparator based on the waveform. First one, the reference voltage is positive reference voltage, and another one negative reference voltage. What happened the output? So the positive voltage output the time varying signal. So Vm. So the reference voltage is a positive reference voltage. So positive VREF. So the output voltage. So in this case, coming to this position, up to this position, there is a voltage is here. So compare this one. The reference voltage is higher than that of the input voltage up to this point. So in this case, the input voltage is less than VREF reference voltage. What happens? The output is minus VSAT. So minus VSAT, minus VSAT. So output V out. So point minus VSAT is here. So the input is exceeding the reference voltage, or Vi is greater than VRA. What will happen? The output is plus VSAT. So this one is going to plus VSAT is here. This is the point, plus VSAT is here. So coming to this point, the input voltage again going to less than that of the reference voltage. So in this case, the output is going to -1 and repeating like this. So whenever the positive reference voltage is applied. So the next one, negative reference voltage is applied. What happened? The output. So minus Vm. So out. So the reference voltage is a negative voltage is here. So these are the points. So in this case, what is the output voltage? So there is a negative VRF is here, negative VRF. So positive input voltage. So input voltage is higher than reference voltage. Reference voltage is a negative voltage. So the input voltage is higher than this negative voltage is here. This up to this point. So the output is plus VSAT. So after this point, reference voltage, what happened? This voltage is more negative than the minus RF. So this one is going to be more negative than this minus VRF. So in this case, what happened? Negative VRF is higher than that of the negative input voltage. So in this case, the output is going to negative VSAT. So this one is so minus that, and this one is plus VSAT. Input. So whenever assume the reference voltage is 2 volt, assume one example. So one and this one is V2. So we can write the reference voltage VID is equal to V1 minus V2. The reference voltage is plus 2 voltage. So the reference voltage is applied to the negative terminal. So V2 is fixed to 2. So what about the V1? Assume V1 is less than that of this one. So what is the output voltage? So consider the V1 is a voltage is here. So this is our point, that is a positive voltage, 2 voltage. So V1 minus V2. V1 is our input voltage because V1 applied to the input terminal. So input voltage Vi is applied to the positive terminal is assumed to be V1. So V1 now assumed to be a negative voltage. So negative voltage is here. So what happened? So negative minus 1 minus 2, that is minus 3 is here. So minus 3 means that is a fixed point is minus voltage, that is minus Vset. Assume now the V1, this is our first case. Now our second case, the V1 is higher than that of voltage exceeding this one. Assume V1 is a voltage and V2 is fixed, the reference voltage is 2 voltage. So difference in the V1 minus V2. So we will the positive voltage, that is 2 voltage, that is assumed to be a positive one, that is our plus Vset. So coming to this case, assume the reference voltage is assumed to be minus voltage. So what happened? So we can predict VID is V1 minus V2. Now V2 is negative voltage, negative of minus 2, that is V1. Now V1 is assumed to be a positive voltage. So assume the voltage is exceeding 1. Assume this one is a 3 voltage. So first case, what happened? The output 3 minus of minus, that is 3 plus 2, that is 5. That is a positive voltage. So whenever the Vin is higher one, so the output is going to be positive one. Next one, second. So the 3 I am assumed to be minus of minus 2 is our reference voltage. So minus 3 plus 2 is here. So what happened? There is a negative one, that is a negative voltage. So that is negative is that is happened this position, and this is positive is happens. So we can make the prediction whenever Vi, these are the points, we can write Vi than reference voltage, and this one Vi greater than V reference. Also we can make this one is what? The Vi is greater than that of V reference voltage, and this one is Vi less than VRF point. Easily predict from this first waveform also. So the next one is inverting. So in the inverting comparator, just opposite this non-inverting comparator. So in this case, so positive and negative voltage, the input is our inverter input. and the reference voltage is approximately with connection of a resistor and a resistor named are same values. So this is our output and negative. So the diagrams. So in this case, two conditions: Vi than VREF, greater than VREF. So what is the output voltage? So than higher one. Now our step just opposite this one. We make the output is plus VSAT. So in this case, minus VSAT, just opposite this one. So we can also predict this one into waveform and also mix by setting away reference voltage, and we can prove this conditions, two conditions. So the first one, positive voltage, what happened the output. So in this case, so forms zero. Vm t. So the reference voltage is positive VREF. So so it- so what happened the output voltage. So the input is less than reference output is a positive so so the input voltage is exceeding the reference voltage. So what happened? And V reference output is negative 1. So minus V sat plus V sat. So again the input is less than the reference voltage, these points. So then is rating. So points A is greater than Vi less than V reference. Writing. So coming to the reference voltage is a negative voltage. What happen in the output of the inverter comparator minus reference voltage. So in this reference, so out plus V sat. So in this positive is here, the reference voltage is negative reference voltage. So the input is exceeding the reference voltage. The output is minus V sat. Moving to this position, negative point is this one. So exceeding this minus reference voltage of the input, what happen? This one is going to and repeating step. So this is the inverting comparator. We can also prove waveform based on the numerical values of the reference voltage. So the first is our reference voltage. Reference voltage is set to positive one, that is VREF is equal to plus 2 volt. So VID is equal to V1 minus V2. So the reference voltage is applied to positive one. So 2 V1 now is 2 is V2. So V1 is 2, setting above the reference voltage is 2 minus, assume the input voltage is a negative voltage, say negative minus 1. So 2 minus of minus, that is plus, that is 3. 3 is positive. So positive voltage. Whenever the input is a negative 1, there is a negative 1, so there is a positive voltage. Now the reference voltage is 2. 2 minus 2 minus, there is a positive voltage is here. The voltage V2 is 4 voltage, that is a 2 minus 4, that is a negative 2, that is negative voltage. So whenever exceeding the one of the reference voltage, the output is going to be negative. So coming to this one, the reference voltage is assumed to negative value. So we can write there is a negative 2 voltage. So assume VID V1 minus V2. Now V1 is reference voltage minus 2. So V2 is minus 3. So what happened? Minus 2 plus 3. That is, what is the value? So in this case, there is a negative is happens. Assume that is a negative voltage. So minus 2 minus of minus, that is 3, minus 2 plus 3, that is 1. So we can make a positive voltage. So another one minus 2 minus, assume to higher voltage is a positive voltage 3. So what happened? Minus 2 minus 3, that is minus 5, that is a negative voltage. So whenever the voltage is a positive voltage, positive voltage is here, the output is going to be negative. Whenever negative voltage is here, so minus of minus, that is 3, minus 2 plus 3, that is plus voltage is here. So whenever negative happen, that is positive one. There is a positive happen, that is negative one. Why? Because of the input is connected to inverting one. Simply whenever input is connected to inverter configuration, the output is a 180-degree phase shift. That is, simply we can analyze this one based on the numerical values of the reference voltage. So this is the comparator, non-inverting and inverting comparator. So now we analyze the working of the another application of comparator, that is zero crossing. So zero crossing, the application of, so of application is here, detector. So in this video we are talking about the zero crossing detector. So we can convert the just inverting and non-inverting comparator into zero crossing detector by reference voltage is voltage is switched to zero voltage. We can make the zero crossing detector. So inverting, so 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 F, so the reference is connected to ground. So we can voltage is so so in this situation the reference voltage is zero. So whenever the input is switched to positive voltage or negative voltage, we can detect the output. Or the zero crossing detector is detecting whenever the input is crossing the zero reference. That is simply why it is called zero crossing detector. So we can write the waveform of the zero crossing detector. So input voltage or output voltage. So maximum voltage is Vm. So voltage minus Vm. So the reference voltage is set to 0. So this is our reference voltage is set to 0. So the reference voltage is set to 0 like this. So in this case, is equal to V1 minus V2. This one is our V1, this one is our V2. V1 minus V2. So V1 minus V2 means minus is minus V2. So whenever the input is positive one, so we can get the output is negative. So whenever negative is happen, that is we can get the positive one. This we can get the output. So that what is the meaning is that whenever the input is crossing to point is here, the input is just crossing. So like this, the input is starting from like this. There is a portion is coming like this. So the input is starting and coming to negative to positive. So the zero is crossed. So whenever zero is crossed, the output is switched. So this is connecting the input is to the inverting one. That way it's going to be negative. Whenever the configuration is non-inverting configuration, the output is like a positive reset. So this one is a inverting configuration of the zero crossing detector. That's why the output is going to minus reset. So in this, the VA is coming and now it's reached to 0 and it's going to negative 1. So just crossing the 0. So there is a switching of the output. So another coming the input negative, so maximum position, and it's going to be positive 1, just reach to 0 and switch to positive voltage. So there is a switching is happens. Then it's going to and it's continuing. So that's why it is called zero crossing detector. So better. So there is a two basic inverting and non-inverting comparator, and one of the application of the. Thank you everyone. Sign off. Jai Hind.